Here we have a SAT math question. There is a quadratic equation that is 21x square positive 41x positive 10 equals to 0. The above equation can be factored into 3x positive a times 7x positive b, where a and b are integer constants, or factored into 3x positive c times 7x positive d, where c and d are non-integer constants. What is the value of a positive c? Okay, first let's factor the given quadratic equation. So here the coefficient of x square in the given quadratic equation is not 1, it is 21. So to factor the quadratic expression we have on the left side, we have to multiply the constant term positive 10 by the coefficient of x square. So when I multiply this positive 10 by the coefficient of x square 21, I am getting positive 210. Okay, now I have to get two factors for this positive 210, so that the product of the two factors over here must be positive 210, and when I add the two factors over here, it must be equal to the coefficient of x, that is positive 41. I think positive 6 and positive 35 will work. So when I multiply positive 6 and positive 35, I am getting positive 210. When I add positive 6 and positive 35, I am getting positive 41, which is a coefficient of x. To get the factor form of this quadratic expression, what I'm going to do is I'm going to divide both the factors, positive 6 and positive 35, by the coefficient of x squared, that is 21. Okay, let me divide the 6 by 21 and 35 by 21. Okay, here we can simplify this fraction 6 over 21. So the greatest common divisor we have for this 6 and 21 is 3. So 3 goes into 6 2 times, and 3 goes into 21 7 times. And here the greatest common divisor for 35 and 21 is 7, and 7 goes into 35 5 times, 7 goes into 21 3 times. So I am getting positive 2 over 7 here, and here positive 5 over 3. Okay, now to get the factor for this quadratic expression, I am taking x over here and x over here. Okay, to get the first factor, what I am going to do is I am going to move this 7, the denominator 7, as the coefficient of x. Then I'm getting the first factor, that is 7x positive 2. Okay, to get the second factor, I'm going to move this denominator 3 as a coefficient of x over here. Then I get the second factor, that is 3x positive 5. Since we have a quadratic equation, it can be equated to 0. Okay, now according to the factor form we have over here, so we must have the factor which contains 3x at first. So here in this factor we have 3x, so we can write this factor at first. So then I'm getting 3x positive 5 times, we can write this factor next, that is 7x positive 2 equals to 0. So now I got the factor form of the given quadratic equation. So in this factor form, I get positive 5 over here and positive 2 over here. So these two values are integer constants. So according to the information we have over here, in this factor from 3x positive a times 7x positive b, so a and b are integer constants. So we can compare this factor from 3x positive 5 times 7x positive 2 with 3x positive a and 7x positive b. So because here we get integer constant positive 5 positive 2, and in this factor form a and b are integer constants, it is given in the question itself. So comparing this and this, what value do I get for a and what value do I get for b? So at the place of a here we have 5 in our factor form. So I get a equals to 5. At the place of b in our factor form we have 2, positive 2, so we get b is equal to 2. So the values I got for a and b satisfy the condition given in the question. So a equals to 5, b equals to 2, both of them are integer constants. According to the question, a and b must be integer constants. Okay, now let's factor the same quadratic equation again, so we have to get non-integer constants at the place over here and here, because there is another factor form given over here, but in this factor form both c and d are non-integer constants. So accordingly we have to get the factor form of the given quadratic equation. Okay, so the same thing I have to do, that is I have to multiply this positive 10 by 21, the coefficient of x square. I am getting positive 210, and now I have to get two factors for this positive 210, so that the product is equal to positive 210 and the sum is equal to the coefficient of x positive 41. So the same thing, positive 6 and positive 35. So whatever factors I got over here, the same thing I'm doing over here. And so to get the factor form, what I am going to do is I am going to divide both the factors by the coefficient of x squared 21. So here I divide this 6 by 21, 35 by 21. But this time I'm not going to simplify this 6 over 21 and 35 over 21 as I've done over here. So what I'm going to do, let me do it in the next step. Positive 6 over, so I'm going to write this 21 as 3 times 7, and positive 35 over this 21 also can be written as 3 times 7, because 3 times 7 equals to 21. Okay, now I'm taking x here and here x here. Okay, to get the first factor for the given quadratic equation, I just move this 3 alone as a coefficient of x. Then I'm getting 3x positive 6 over 7. Again, I should not write 3 over here because the 3 over here is moved as a coefficient of x here. So I got the first factor of the given quadratic equation. Okay, now to get the second factor, I move this 7 as coefficient of x. So when I do so, 7x positive 35 over 3. So I'm equating to 0. So in the first case, I moved 3 as a coefficient of x because I have 3x over here. But when I try to get the second factor, I didn't move this 3. I moved this 7 as a coefficient of x because here we have 7x. That's the reason. Okay, here I have 6 over 7, 35 over 3. 6 over 7 cannot be simplified to an integer, so it is a non-integer constant. So the same thing, 35 over 3 cannot be simplified to an integer, so this is also non-integer constant. So here I have a non-integer constant, here I have non-integer constant. According to the information we have in the question, so in this factor form, the c and d are non-integer constants. So comparing this and this, what values do I get for c and d? So c is equal to, at the place of c in our factor form, we have 6 over 7. So the value of c is 6 over 7 and the value of d is, so here we have d, at the place of d we have 35 over 3. Okay, so here the values I got for c and d satisfy the condition given in the question. So because of the values we got for c are non-integer constants. Okay, now I got the value of a, I got the value of c. A equals to 5, which is an integer constant, and c equals to 6 over 7, that is a non-integer constant. So according to the question, we have to find the value of a positive c. That is, we have to add a and c. So let me do it, a positive c. So for a, we know that it's an integer constant 5. We can plug in 5 for a. And for c, we have a non-integer constant, that is 6 over 7. So we have to add them. So a positive c equals to, here I have to add a fraction and an integer. So whenever I want to add a fraction and integer, and I want to do subtraction between an integer and fraction, what I need to do is I have to multiply the integer part by the denominator of the fraction. So once I'm done with this multiplication, I can take this 7 as a common denominator. Okay, first let me multiply this integer 5 by 7, then I'm getting 35 positive 6. So already I have multiplied this integer part 5 by this denominator 7. Since I have multiplied, I can take this 7 as a common denominator. So finally I'm getting a positive c equals to 35 positive 6 will become 41 over 7. I got the value of a positive c. So the value of a positive c is 41 over 7.